So Python is the language that we'll use mostly on the Mercury robot. I don't know if any of the other robots will use Python. Probably not. Has anybody worked with like a programming language before, like C#, Java? Okay. Who's worked with like just C or C# or Java? A couple of you? Okay. So Python has a lot of the same concepts as those languages, but the syntax is a lot different. For instance, there are no like curly braces that you use for your if statements. You just tab over, and that's like your code inside a curly brace. So basically, tabbing is very important in Python. You can get messed up like a lot if your tabs are off. So it kind of forces you to like learn proper indentation and things like that. Another thing that's kind of different about Python is you don't declare a variable type. Python just kind of assumes what you want to use. So like instead of saying like int value equals 0, like you would in like C# or Java, you just say value equals 0. And then that's your statement. So Python kind of like assumes what you're going for without you having to tell it, okay, this is what I mean. So you kind of have to know like what data type you're using so that like you can like convert it to a different data type later if you need to. I'll kind of show an example of that. Another thing that's different is it's a scripted language, so you don't have to compile it yourself. It does that for you. So like for Java, you would have to type javac and then file.java, and then you would have to run it with Java file. So there are like 2 steps involved in running your code. In Python, it's just python file.py. There's no compiling step. It does that for you on this same line. So that's another kind of good thing about this. So I guess I'll kind of get into some of the code now. Does anybody have any like opening questions or anything? Yeah.
Who uses Python?
A lot of people, like a lot of stuff in industry uses Python. You can use it for like web development stuff. You can use it for like unit testing for like different softwares, like with hardwares, things like that. It's just like a good language to know if you're going into the industry because a good amount of people use Python for a lot of different stuff. So yeah. Anything else? Okay, so for like the code portion, I figured I'll just like kind of go through some of the like main concepts that you would learn in a class like 200, but I'll show it to you in like half an hour instead of an entire semester. So yeah, so kind of the first thing is like getting user input from the command line. So you can say like num1, and then the like command to get user input is input, and then you give it whatever you want to say. So like enter first number, and then that will store the value that the user gives you into num1. Kind of going back to what I talked about with the variable types, input returns a string variable type, but we want to use num1 as an integer. So we have to cast it to an integer using this cast. So it just says, okay, everything that we get from input, everything that we get from the user, we want to make that an integer data type. So then let's do that same thing for a second number. So then we can say, like we can do a print statement to say like this is your first and second number. So first number is this, and so what I did here is just some string formatting that Python sets up. So you do an open and closed curly brace if you want to put some value into your string. And then if you have that, you need to say dot format and then put in whatever variables you want to have go into those curly braces. So here we have a curly brace set here, and num1 will go in there. And then for the second one, we'll have num2 go in there. So we'll just run this from the command line and see what it says. So in our first number, we'll say 4. In our second number, we'll say 10. So first number is 4 and second is 10. So that's one of the ways to get user input. And now I'll kind of talk about like if statements and some other data types. So if statements are used to check like if two numbers are equal to each other, then do this. If they're like if the first number is less than the second number, do this. Otherwise, we can have some other set of code run. So if num1 is equal to num2, and then here, instead of doing curly braces, we need to tab over. And this is kind of saying, okay, if the two numbers are equal, then we're going to do this part. So we'll say print the two numbers are equal. And then once we're done with doing all of the stuff we want to do in the if statement, we just back out to the previous level of indentation. And then we can say like else. So that means like if the two numbers are not equal, then do this. So one of the other things we can do is say if the two numbers are not equal, but one number is like, for instance, the other number -1. So we can like do multiple checks of the same two variables in like the same if statement block. So in like C# or Java, it would be like else if num1 is like less than num2 or something. But in Python, it is ELIF, just like a shortened version of that. So we'll say num1 equals num2 -1. And then like all of your like if statements or loops or anything like that, they need to end in a colon at the end of the line. So then tab over and say print first number is 1 less than the second. And then we can do like as many elif statements as we want within that same block, but then we can have like an else statement saying, okay, nothing else return true, so what do we want to do if that happens? That's where you set up an else block. So we'll say print numbers are not equal, and then I'll just get rid of this one. Comments in Python is like a hashtag for a single line, and then if you want to do like a multi-line comment, it is 3 sets of double quotes at the beginning and end of wherever you want to do it. So that's just how you do comments in Python. So I'll run this. So we'll say the first number is 4, the second number is also 4, so the two numbers are equal because this statement returned true. So now if we say like 4 and 5, then the first number is 1 less than the second number. And then if we say like 3 and 9, the numbers are not equal. So that's just kind of the setup for like if-else statements in Python. So I will get rid of all this for now. So the next thing I'll go into is arrays in Python. So arrays are just a way for you to put like multiple variable or like multiple items inside of one variable. So like in Java, you would have like an integer array, a string array, a character array. In Python, they're a little more flexible. You can put any data type inside of the same array. So like you could have one array that holds integers, strings, and like something else, like a character or something. So Python's a little more flexible with their variables. For now, I'll just stick with using integers because it's simpler. So we can say like array equals, and then the square bracket is kind of like the definer for an array in Python. So we can say like 5, 10, 15, 20. So then this is an array of the numbers 5, 10, 15, and 20. And then if we want to like go through and like print each of those numbers, we can set up a for loop. So we can say for I in range 0 to len array. So what this says is I'm going to declare a variable called I, and it's going to loop through like the number of times between 0 and the length of the array. So there's 1, 2, 3, 4 items in the array. So it'll go 0, 1, 2, 3, but then it will not go to 4. So it includes the first number in the range, but it stops right before the last number in the range. So this will go ahead and print everything or it can index everything in the array. So we can say print array bracket I. So these brackets say in the array here, we want to print out the item at the ith like position. So the array numbering starts at 0. So like this, the 5 is at position 0, the 10 is at position 1, 2, and 3. So that's one of the reasons like the range function is nice for when you're using for loops on arrays, because you can say start at 0 and then go to the length of the array, but it will stop before it gets to like 4, because if you had like try to do array position 4 out here, then it wouldn't like that. So this is like one of the nice ways to do range. So if we run this, it should just give us 5, 10, 15, 20. Or another way to do the for loop, we'll set up a total variable. You can loop through the items. Instead of doing like the position, you can do a for loop through the individual items in the array instead of doing a counter and then accessing that item. So we can say for item in array total plus equals item. So this will just add whatever item is at like the first position in the array, it'll add that to total. And then the next time through the loop, it'll add the item at the second position, and so on and so forth throughout the entire loop. So then here we'll say print total, and then it should give us all of these numbers added together, which should be 50. Yeah. So there it gives us 50 as the last line after this for loop went through the entire array. Yeah.
What does that do if you had different types of items in the array?
This part?
Yeah, would it just add, like add the ASCII?
I don't know. It would either add the ASCII or break. Let's do. So we'll put in a string there just to see. I'll take out this part. Yeah, so it doesn't let you add integers and strings together. So you would have to say like total equals int item. But so yeah, if you want to loop through the items and add it to something, you want to make sure that it's all like the same data type. So that is the basics of like arrays and for loops. Does anyone have any questions about that? All right. Yeah.
You said like if you put int in front of item or whatever,
Yeah.
will disregard the string in it?
I don't know if it will disregard the string. Let's find out. Okay, so yeah, it just, yeah. Oh, I did, didn't I? Well. Okay, yeah, so it doesn't like it if it's like a string. So another data type that we might end up using on the Mercury robot is a dictionary. So a dictionary is basically an array, but instead of like individual items, it's a set of 2 items, a key and a value. So the key is what you can use to like access the like value. So I'll show an example of like something we might use on the robot. So like we might use a dictionary for the controller. And then in Python you use the curly brackets to define a dictionary. So like we can use like a set of a key and a value for a button on the controller and then the value of that button. So we can say like the X button has a value of 0. The like A button has a value of 1. And then so on and so forth throughout the rest of the controller. Like the right stick vertical has a value of 7, we can say. So then this will just like be an easy way to like kind of group together a couple different items and like have an easier way to go through it. So we can loop through the items in the dictionary using a for loop. So if we say for item in controller, then we'll print out like item and then we'll say item, and then to get the value that corresponds with the key that we're given, we do controller item. So it's sort of like an array, but instead of giving it an index, you give it a key. So we'll go through that. So item X on the controller has a value of 0. Item A on the controller has a value of 1. And then item right stick vertical has a value of 7. So that's just like another way to kind of combine 2 different arrays. So any questions about that? All right. Another thing we will definitely use on the robot are methods. So methods are like an easy way to like break up the code and like allow you to reuse it a lot. So we can have a method to like get the data from somewhere. We can have a method to update a motor. We can have a method to get sensor data. There's a lot of different ways we'll use methods on the controller. So to define a method in Python, you do def, or like define, and then we'll say update motor speed. And then we can pass it in some value we want to update the motor speed to. So then in here somewhere we would like update the value in hardware. But since we don't have that set up right now, we'll just do a print statement. So then this will let us do basically the same thing kind of as many times as we want. So we just call the method, give it a value, and then the method will run its code, and then it will return back to where it was in the original code. So to call a method, we say update motor speed, and then we give it some speed value. So we can say like 4. And then we can say like 34. And then we can say 0. So then let's run this. So the motor value is 4, 34, and then 0. So you can have a lot of different methods doing a whole bunch of different things. Any questions about that? Yeah.
Where do you put return values?
If you want to do a return value, like if you want your method to return some value, like say, you can just say return like value plus 5. So like this isn't a great example for like why or when you would want to return something, but that's kind of how you do it. You just want to make sure like you put a return statement at the end of your method. So, and then kind of something we can use to hold a lot of different methods together is a class. So a class is kind of like a blueprint for how something should run. So we can have a class for our motors, we can have a class for our sensors, we can have one for like our servos and whatnot. So it's just kind of a way to like reuse the same like objects. So I'll show an example with setting up a motor. So with the motor, the value we want to give it is probably a speed. So we'll say speed equals 0. And then once we say, okay, let's make a new motor, we want to make sure the speed is set to 0. So that we do that in an initializing function, or like a function that gets called every time a new motor is created. So that's underscore underscore init underscore underscore, and then you pass in self. So self kind of says, okay, this is a reference to like the current object of the class that I'm using. So it like basically references itself instead of like some other object of that same class. So here we'll make sure speed equals 0. If this gets set to like 30 for some reason, we want to make sure that every time we create a new motor, we start it as 0, so it's like not moving or anything. And then we can pretty much just drag this code or this method into the class. And we want to make sure that we give it a reference to itself using self. And then we can say self.speed equals value. And then right here, it really doesn't matter if we use value or self.speed since they're the same thing here, but I'll just do self.speed. So now that we have a class for our motor, we can set up multiple like different objects of that. So we can say like motor1 equals a motor. So here you just give it the name of the class and then an open and close bracket, since it doesn't ask for any parameters here like we did in the method up here. So then we can say print motor1.speed, and then that should return 0 even though it says speed up here, since when we call motor here, this initializing function gets run. So then we can say motor1.update motor speed, and then say 30. So then let's run this. This is why tabs are important, because it throws errors. All right. All right, so yeah, that's kind of an example that shows how like classes work. Any questions about that? Yeah.
It's not about that, but what software are you using for Python? Like, what, the text editor?
This is just a default one that came with Ubuntu, which I have set up on like a VirtualBox. We'll use Visual Studio Code mostly down in the lab for this, but pretty much any text editor. And then one last thing that I'll talk about, it doesn't really have to do with Python, but it's like an important concept to kind of get a general idea of, is like synchronous versus asynchronous code. So everything that I've done here so far has been run synchronously, which means it just goes line by line and does everything in order. But asynchronous code can do parts of your code at once, and then it can skip to a different part of your code and run that, and then come back to here. So kind of an analogy to that I heard was like, think of like if you're running on a race, that could be like a task that you need to complete. But then like in the middle of your race, your shoe gets untied. If you're running the race synchronously, you would have to finish the race before you can start the new task of tying your shoe. If you do it asynchronously, then in the middle of the race, you can like stop, tie your shoe, which is starting the new task, finish that, and then go back to your longer task of like finishing the race. So that it just lets you like stop a long task that you're on, like start a new thing, and then go back to the original one where you left off. So to kind of show why we want to do that, I'll pull up this example that I have. You don't need to understand all of this, just kind of the general idea. So basically what we want to do is get some data from a website. We want to do that 3 different times. We want to find the factorial of a number and then the factorial of another number. So basically we have 3 tasks we need to complete. And the way we have it set up now, we have a sleep for 1 second every time we go through 1 loop of the factorial. And then we have a sleep for 3/4 of a second every time we get new data. So with time.sleep, that is a synchronous function. So when it hits time.sleep, Python doesn't let anything else run for that amount of time. So it just kind of sits there doing nothing for 1 second or so. So I'll run this example how it is now. So as you can see, it kind of goes through 1 task at a time until it's finished. And it goes to the second one, and then it gets the data. And it says final time is 8.478-ish seconds. So it took like almost 8.5 seconds to run all of those tasks and complete them synchronously. So now if we put in an asynchronous wait for the same amount of time, when it comes to this wait, it'll say, okay, I'll stop this function now, but is there something else I can run while this function is like sleeping? So we'll run this one. So as you can see, it's doing it a lot quicker. So now it does it in about 3.3 seconds, which is good for us because we want things on the robot to run as fast as we can with as little downtime as possible. So as you can see here, it starts with task A, and then it gets to its sleep, and then it starts on task B while task A is sleeping, and then it does its sleep. So then it goes to the next item, which is getting some user data from the website or from some arbitrary website. So that's just an example of why we want to use asynchronous code. You don't have to understand it fully. I know I don't, but this is kind of just an overview of why it's good. That was about all I had. Does anyone have any questions or anything else they want to see? Yeah.
What's the best way to learn Python or get better at it?
Best way to learn would just be kind of throw yourself into some easy stuff, get to know like some of the basics, and then work up to harder stuff. There's a lot of resources online, like if you just like search Python tutorial, there's a lot of different things. There's the Python like official documentation. That would be more for like when you want to know what like one function does. I wouldn't recommend that as like a get to know Python. That's more of like a reference for like each function, each method, like kind of like everything you need to know about every function in Python or every native function in Python. Something that would be better would be like W3 Schools, Tutorials Point. Code Academy is another good one. They just kind of give like simple examples, kind of like I did of, okay, here's an if statement, here's when you would use it, here's how you use it, here's some of the problems you might run into, things like that. So just going online, looking at different websites, and then like if you get stuck, you can like kind of search the error that you had, and then there's a good chance that somebody else somewhere in the world had that same error and asked about it online, and then someone a lot smarter answered their problem, or like answered their question, solved their problem. So you can kind of use that same like thing that they did. So yeah, just go online, go through some tutorials on websites, and yeah. Yeah.
What about running
Subprograms.
subprograms?
So that's kind of like what I mentioned in here with like asynchronous stuff where you have one task running, it waits, and then you run another task while that's like waiting on something. Is that kind of what you mean?
I guess. I don't know too much about programs.
Okay. Yeah, you can also do like multi-threading things. So like running two things at the same time or like running things in parallel. We won't use a whole lot of that on the robot, if any. So I didn't really cover it.
We did for servos. We'd spawn a new thread, have that control the servo, and then merge it back in.
Okay.
So not much, really simple.
Yeah, okay. So yeah, we might cover that later once we get into that more. But anything else? All right. I'll probably post this one that I created in the Discord or something somewhere, just as reference for you guys or for anybody else that wasn't able to make it. So, yeah.